Do you guys remember what a negative in the exponent means? You learned this in your introductory algebra class, but you may have forgotten. So in this definition, we're talking about a to the negative m over n. So let me remind you what you learned in your last class without the fraction. If you had a to the negative n, then you learned that, oh, that's the same as 1 over a to the positive n. Remember that? So the negative in the exponent doesn't have anything to do with the sign of the number, whether it's positive or negative. It means take reciprocals. A to the negative 1 over a to the negative n is equal to 1 over a to the positive n. Another way you could write that is 1 over a, the whole thing to the n. You guys see why? Because of that rule of exponents that says the exponent splits up over division. So you could think of this guy, this 1, as 1 to the n. You can think of 1 as 1 to the anything. And then kind of go backwards from that property that you know where the exponent. So this guy, if you go to here, you're familiar with that property. The exponent splits up over division and multiplication. This is division, so 1 to the n, a to the n. So it's important to realize in certain situations, you may want to write it as 1 over a to the n. Other situations, 1 over a, the whole thing to the n, they're equivalent. All right, now that's what you learned in a different life, right? So how does that transfer now to a to the negative m over n? Well, it's the same. It's just now we're allowing for fractional exponents. So you could rewrite this as 1 over a to the positive m divided by n. M over n is acting like n acted in that above definition. Okay? So the negative in the exponent means exactly the same thing as it used to mean. It's just now we're allowing for fractional exponents. Okay, so 8 to the negative 2, using just the definition of negative exponent, rewrite that for me. 1 over, that's the same as 1 over 8 squared. Or, now, you don't need to write it this way, but I just want to point out, it's also the same as 1 over 8, the whole thing squared, isn't it? You don't need that for this problem, but it's handy to remember that for other problems. Okay, so what's 1 over 8 squared? 1/64. Yes? So either of those answers are right? Well, okay, yeah, but the one in orange, you're going to want to split up anyway so you can get 1/64. So, yeah. So this could be an intermediate step if you wanted to remember it, right? But you're going to split it up anyway, so we usually, in a situation that's as simple as this, we usually don't consider it. Okay, how do you think it works going the other way? 1 over x to the negative t. It actually works exactly the way you would want it to work. So what would you want this to be? X to the positive t. So if the operation is multiplication, or you just have a lone factor in the denominator, and it's brought to a negative power, it flips up to the numerator, right? You can think of this as being over 1, right? So why does that work? Well, so I mean, you're normally not going to show any work. You're just going to go from there to there. And that's fine, but you should know why it works. It works because 1 over x to the negative t is really 1 over x, the whole thing to the negative t. The negative means take reciprocals, and once you take the reciprocal, the negative goes away. And then you get x over 1 to the t, but that's the same. Okay, x to the t over 1 to the t, that's the same as just x to the t over 1, which is just x to the t. So the part in orange is just kind of showing you why it works, why it's consistent with the definition that says, oh, the negative in the exponent means you take reciprocals and then lose the negative. But again, that part in orange you don't need. Okay, so what's the most convenient way to think about it when you have multiple factors? And the operation is multiplication, right? So this won't work if you're adding two of those things together. The easiest way to think about it in one like part C, where you have 3 to the negative 5 halves, a cubed, b to the negative 7 thirds. The easiest way to think about this one is think of it as 1 fraction over 1. You can do that, right? And then any of the factors brought to a negative exponent goes down to the denominator with a positive exponent, so lose the negative, and it ends up as a factor in the denominator. And vice versa. If you had in the denominator a factor with a negative exponent, it would flip up to the numerator with a positive exponent as a factor. That's the easiest way to think about it. So in other words, this 3 to the negative 5 halves is going to end up in the denominator as a factor. So you don't need the 1 times, but just to be consistent, 1 times 3 to the positive 5 halves. And again, if you wanted to, you could lose the 1. Now it's not doing much, is it? And then is the a cubed going to go anywhere? No, it's a to the positive 3. It stays there. What about b to the negative 7? It's going to flip down and become b to the, or 7/3. It's going to flip down to be b to the positive 7/3, isn't it? That's it. Okay, let's try this one. In part D, you have in parentheses a fraction brought to a negative exponent, right? So in part D, you have 2ab divided by 3c, the whole thing to the negative 5/6. So how could you rewrite this? You could, but I don't think the intention, that's the intention here. I think the intention is just to get rid of the negative exponent. So I would actually leave it on the outside, make it positive 5/6, and then just take the reciprocal on the inside, get 3c over 2ab. And then it is true that if you wanted to lose the parentheses, that the 5/6 would be attached to both the numerator and the denominator, but that's just going to become really messy if I do that, so I'm just going to stop there.